So yeah, this is our first method, and it's the only method we're going to be going over in 8th grade is solving these by graphing, which is why in the Bell work we did a graph, because, well, we should have been doing that. We've been doing a lot of it. And in fact, the mastery quizzes from Unit 3, there's still several of you that need to pass those, so you'll need to do those as soon as possible. But yeah, if you can't graph lines in Unit 3, then in this unit, which is just one lesson, you may find this extraordinarily difficult. Remember too, if you can't pass the mastery quiz, you can't pass the classes, this class. But if you can pass the mastery quizzes, then it's impossible to fail the class. So the solution is found at the point where the two lines intersect. Okay, so if we were to look at a graph like this one, and we had two lines on this graph, doesn't really matter what they look like. I don't know, something like this. I guess that's more what I wanted. So you may graph a line like this one, and then it's possible you may have another line like, oh geez, I don't know, something like this, okay? Who knows what the lines will look like? Sometimes they'll just be straight and horizontal and vertical. Doesn't really matter, but the solution to a system like this, when we have two lines on a graph, is the point where the two lines come together. So I'm going to pretend like these two came together at that point. And it's just the ordered pair. This would be the solution to this system. So this ordered pair, I see the x is at -5 there. And then the y there is at 6. So this would be the solution, the actual solution to this system. Now, if we think about what a solution to a line means, or a point on a line, it would indicate that whatever this equation is for this red line, it would make it a true statement. And the purple line, whatever equation this came from, it would also make, this ordered pair would make it a true statement, okay? Now, in the first couple questions we're going to see, it is possible that you can have a point be true for just one of the equations, like let's say this point. So this ordered pair that I have in orange there, which is 7, -5, it would make the purple line true because it's actually on that purple line. But see how it's not on the red line right here, right? So that would make it, that would mean that it would make this equation from the red line false, okay? But only the green point would make it true for the purple and true for the red as well, okay? So it has to be true for both. Now it is possible from time to time you may see a point that's just kind of out here like this one. That is the ordered pair 10, 5. And we can see since it's not on the purple line, it would make it false. And since it's not on the red line, it would also make the red equation false as well, okay? Because it's not on either lines. It needs to be on both lines in order for it to be true. And the only way that can happen, at least with straight lines, is if they come together at a point, okay? So just based on what we saw on the last slide with the objective, see if you can solve these two. You're just looking at 4,1 and -3,3 and seeing if it is a solution for the given set of system of equations right there. 1 minute, go. So these first couple questions are just asking us, really, is this the point of intersection for these two equations, or is this the point of intersection for these two? And the only way that can happen is if it makes both of the equations true, if I replace the two values that they give us from the ordered pair into both equations. Now I'll remember though, if I'm going to test both, but I'm going to start with the first equation. If I found that it was false, then it wouldn't be true for both, so I would know that it's not a solution to the system of equations, okay? So I'm going to start with x minus y equals 3. X minus y equals 3. And I have my ordered pair here. I'll put it in green. So I can see the x value is 4 and the y value is 1. So in my equation, x minus y equals 3, I replace the x with 4. And then I replace the y with 1. Because that's the x value is 4 in that ordered pair, and the y value is 1. And then I just see if it's true. So I'm going to put a question mark over the equal sign, because I'm not sure if it's true yet, although some of you do. And I say, well, 4 minus 1 is 3. And does 3 equals 3? Yes, that's true. So since this first one is true, of course, it means that 4, 1 is actually on the line. If you were to graph this equation, this ordered pair would be on that line. But is it going to make the second equation true? Let's find out. 2x minus 3y should equal 5, but let's replace the x and y values with the values they give us. So the x value from that ordered pair is 4, and the y value in that ordered pair is 1. Of course, you could just type this into the calculator with parentheses and all, and then it would actually simplify it for you, but I'm going to do it by hand. 2 times 4 is 8, 3 times 1 is 3, just order of operations stuff. And again, we're testing for truthfulness on this one. So does 8 minus 3 equals 5? Yes. So that is also true. So since it was true for both equations, 4, 1 would be the solution to the system. So I'm going to say yes, it is the solution to the system. So that's number 1. 4, 1 was that ordered pair. Now number 2, it gives us a different ordered pair. And I'll put this one in orange. Again, the x we can see is -3, and the y value is 3. So I need to test both equations, or at least one, to see if it's true or false. Again, I'm going to start with that first equation. It doesn't really matter which one you start with. But if I found that this equation was false, I wouldn't need to test the second one, because it needs to be true for both in order for it to be a solution to the system. So I'm going to replace the x value with -3 there. And I'm going to replace the y value with 3, because that's the two values from the ordered pair, x and y. So 3 times -3 is -9 minus 3. And yeah, we are testing to see if this equals -12, so a question mark over the equal sign. -9 minus 3 gives me -12, which does actually equal -12. So that's true right there. Since it's true, I do need to check the second equation and see if it's true. So that's x minus y equals 0. And I know the x value is -3 from the ordered pair, and the y value is +3 from the ordered pair. Now be careful on this one, because if you do this in your head, a lot of students make the mistake and say -3 minus 3 is 0, but that's not true. We are testing for truthfulness, so we got the question mark over the equal sign. Just doing the calculator just to make sure. -3 minus 3 is actually -6. Well, -6 does not actually equal 0. That's false. Okay. Since it's false, then the original ordered pair there, -3, 3, is not a solution. So I'm going to say no, it is not a solution. But again, it's not a solution to the system, which means it needs to be true for both. Eventually, it's possible you could see up to like 3 or 4 equations. Most likely 3, though.